Good day, everyone. My name is Elnalinju de las Peñas, and I am the reporter for the lesson 4, the Nano World. We are two reporters on this topic, and we divide it into two, and I am the first reporter. So I'm going to discuss the nanotechnology, the nanoscience, how small is the nanoscale, how to view nanomaterials, and the nano manufacturing. So let's begin. Scientific researchers have developed new technological tools that greatly improve different aspects of our lives. The use of nanoscale is one of the important interdisciplinary area generated by advancement in science and technology. Scientists and engineers were able to build materials with innovative properties as they manipulate nanomaterials. Indeed, research and application of knowledge in nanomaterials will continue to bring widespread implication in various areas of the society, especially in healthcare, environment, energy, food, and agriculture. So, the nano world. The nano world mm, refers to the realm of objects and phenomena that exist at the nanoscale, which is typically defined as being between approximately 1 to 100 nanometers in size. This is incredibly small scale that is difficult to comprehend as it is much smaller than the visible to the human eye. The nanoscale, many materials exhibit unique properties and behaviors that are not present at larger scales. For example, the nanoparticles may have different electrical, optical, or magnetic properties compared to bulk materials at the same composition. But the study of nanoworld is known as nanoscience, and it involves the exploration and manipulation of matter at the nanoscale using a range of tools and techniques such as scanning electron microscopy, atomic force microscopy, and nanofabrication. So, as we dig in deeper in this topic, we will get to know these tools and techniques. So, first is we have here the nanotechnology. Let's get to know first what is nanotechnology and nanoscience. Their difference, no? The nanotechnology refers to the science, engineering, and technology conducted at the nanoscale, which is 1 to 100 nanometers. And the nanoscience is an interdisciplinary field that involves knowledge from physics, chemistry, biology, engineering, and material science. It involves the use of advanced tools and techniques such as scanning probe, microscopy, electron microscopy, and the nanofabrication methods, as what I have said earlier. So when we talk about science, it talks about the experimentation, the discoveries, what are the techniques that they are being used, and the nanotechnology are kanang the science that they are conducted kung paunsa, no? So that's it. So the nanoscience and nanotechnology employs the study and application exemptionally small things in other areas of science including material science, engineering, physics, and biology and chemistry in NN 2017. The concept of nanotechnology and nanoscience started at December 29, 1959 rather, when the physicist Richard Feynman, a physicist, discussed a method in which scientists can direct and control individual atoms and molecules. In his talk, "There's Plenty of Room at the Bottom," during the American Physical Society meeting at the California Institute of Technology. Methods of the nanotechnology and the nanoscience, their concept is being discussed by Richard Feynman, a physicist, in December 29, 1959. And the term nanotechnology was coined by Professor Norio Taniguchi, a Japanese professor, a decade after the dawn the use of ultra-precision machining in 2017. So how small is the nanoscale? So a nanometer is a billionth of a meter at 10 over negative 9 of a meter. So manipulation of nanomaterials needs a depth understanding of their types and dimensions. The various types of nanomaterials are classified according to their individual shape and sizes. They may be particles, tubes, wires, films, flakes, or shells that have one or more nanometer size can take advantage of their exceptional characteristics. So the nanoscale refers to the size range of objects or structures that are typically measured in nanometers or nm, which is a billionth of a meter. To give you an idea of a scale, um, we have here an example. This one, okay, a DNA. A DNA is measured 2.5 nanometers diameter, while the bacteria is 2.5 micrometers long and the large raindrops is 2.5 millimeters diameter. But to give you an idea of a scale, a human hair is typically around 100,000 nanometers in diameter, while a red blood cell is around 7,000 nanometers. So very, very small, very tiny, and very tiny. So that's why it is called nano. At the nanoscale, materials and devices exhibit unique properties and behaviors that are not present at the larger scales. So the the nanoscale, the nanometer, kanang they have a exhibit unique properties. It's because they can measure a very small scales of a particles. These properties arise due to the increased surface area to volume ratio of a material and the quantum mechanical effects that become dominant at this scale. For example, some materials become more reactive or have different optical or magnetic properties of the nanoscale. Just how small is the nano? In the International System units, the prefix nano means 1 billionth, as what I have said earlier. So it's difficult to imagine just how small that is. Not just how small that is. So here are some examples. The sheet of a paper is about 1,000 nanometers thick. Imagine the thick of a paper is a 1,000 nanometer thick. And the strand of a human DNA here is 2.5 nanometers in diameter. And and as as far as I remember, you can't it's not visible in the naked eye of a human to see a DNA. Kanang dapat siya gamitan og a very kanang grabe siya kanang grabe ang lens, ang magnification sa microscope para makita nimo ang DNA to make it visible pero dili pa jud kay siya grabe ka klaro. Imagine how tiny it is. So there are 25,400,000 nanometer in 1 inch. In 1 inch. A human hair is approximately 80,000 to 100 nanometers wide. A single a single gold atom is about of a third nanometer in diameter. 1 nanometer is about a long of your fingernail grows in 1 second. So very very small, very tiny nga dili jud siya makita sa imong naked eye. So about the NNI, it it stands for the National Nanotechnology Initiative. NNI is a US government research and development R&D initiative. Ever 30 federal departments and independent agencies and commission works together toward to shared vision of a future which is ability to understand and control matter at the nanoscale leads to the ongoing revolutions in technology and industry that benefit society. The NNN or the National Nanotechnology Initiative enhances integ- interagency coordination of nanotechnology, supports and shared infrastructures, enables delivering resources while avoiding duplication, and establishes shared goals, priorities, and strategies that complement agency-specific mission and activities. So, the National Nanotechnology Initiatives are it is a government research of the US that kanang works for future or the ongoing revolution of technology by the use of nanoscale, the nanotechnology. Okay. So that's it, the nanoscale. Dili dili makita, dili makita o di na to mailhan nga ing ani kaning mga raindrops, the bacteria, the DNA or the strand of a hair without the nanoscale, no? This is the the tools na ginagamit para makita ang mga gagmayng mga butang, particles. Okay. So, how? By the use of the nanomaterials. How to view the nanomaterials? So here, how to view the nanomaterials. Scientists use special types of microscope to view minute nanomaterials. During the early 1930s, scientists used electronic microscopes and field microscope to look at the nanoscale. The scanning tunneling microscope and atomic force microscope are just among the modern remarkable advancement in microscopy. These are the engineers and inventors nga nagbuhat ng mga microscope to view the nanomaterials. Paunsa makita by the use of the microscope. So first we have here electron microscope. German engineers si Ernest Ruska and Max Knoll built a first electron microscope during the 1930s. This type of microscope utilized a particle beam of electron to light up a specimen and develop a well-magnified image. Electron microscope produce higher and better resolution than older a million times, while conventional light microscope can a million times with magnify objects of 1 to 1,500 times only. Scanning microscope or the cm, and transmission electron microscope terms in the two dual types of electron microscope. So these are the inventors, the engineers rather, German engineers, si Ernest Ruska and Max Noll. The first, the first kanang kanang nagbuhat build electron microscope during the 1930s. Gitawag nila og electron microscope, and one of the best microscope because it has a high resolution para ma-view ang mga nanomaterials. The electron microscope, and it has, and nasiyay two types of electron microscope, mao ang SIM and the TIM. Okay? The scanning electron microscope and the TIM electron microscope. As you can see, here in the scanning electron microscope, ang tapad niya nga picture, it is a spider, nga giscan niya ang spider, and muni siya ang nakita sa pag-scan. This one. So, ingani day ang panit sa spider. Gamit ang pag-scan by the use of the SIM, the scanning electron microscope. The scanning transmission electron microscope, this one, the SIM, is similar to STEAM with a scanned electron probe. But with thick samples, electron microscope similar to SIM, but for wait lang. Okay, and the other one is the TIM, the TME, the transmission electron microscope. The transmission electron microscope, where shift electrons go through a thin sample. Mga nigpis nga sample. Ato, the other microscope para ma-view ang mga nanomaterials is the atomic force microscopic, the AFM. It was first developed by Gerd Binig, Calvin Quate, and Christoph Gerber in 1986. They are the atomic force microscope or scanning force microscope is a very high resolution type of scanning probe microscopy with demonstrated resolution in order of fraction of nanometers, more than 100 times better than the optical diffraction limit. So a very high resolution, so maklaro kaayo siya pag-ayo. An atomic force microscope on the left with a controlling computer of the right, as you can see here in the picture. This one. Okay, the right side is the controlling and the left side is the right side is the atomic force microscope on the left side, this one, and the other side is the controlling. Si Jerv Binig is a professor. Si Calvin Quate is an inventor. And si Christopher Gerber these three person here are the first develop an autonomic force microscope which has a very high resolution of scanning. So, and the last one that are na pwede natong magamit to view the nanomaterials is the scanning tunneling microscope. This special type of microscope enables scientists to view and manipulate nanoscale particles, atoms, and small molecules. In 1986, Gerbenig and Heinrich Rauer won the Nobel Prize of Physics because of this invention. They invent the scanning tunneling microscope. So the scanning tunneling microscope is a type of microscope used for imaging surfaces of atomic level. So the reason why nadaog this research, this invention, it's because grabe ka sharp, extremely sharp conducting tip that can distinguish the features of smaller than 0.1 nm with a 0.1 mn or deep resolution. This means that individual atoms can routinely be imaged and manipulated. The most scanning tunneling microscope are built for the use of ultra-high vacuum in temperatures approaching absolute zero. So, this microscope is extremely sharp nga makita gyud ang pinakagamay na 0.1. That's why it won in the Nobel Prize in Physics. Ang invention ni George Binig and the Heinrich Rauer. So, that's cool. That's why nadaog siya because of the extremely sharp imaging nga makita gyud ang grabe kagamay ni particles, the nanomaterials. Okay, let's move on to nano manufacturing. Manufacturing is refers to a scaled up, reliable and cost-effective manufacturing of nanoscale materials, structures, devices, and systems. It also involves research, improvement, and incorporation of processes for the construction of materials. Therefore, nanomanufacturing leads to the development of new products and improved materials. So it means that the nanomanufacturing is a process of producing nanoscale materials, devices, and systems in a controlled and scalable manner. It involves the use of advanced technology and techniques such as molecular self-assembly, lithography, and nanoscale 3D printing and create nanoscale structures and components. May lang sa diari sa sunod nga slides nakita nato ang iyang mga examples. So, the goal of nano manufacturing is to develop new products and technologies that are more efficient, cost-effective, and sustainable than existing ones. It has the potential to revolutionize a wide range of industries, including electronics, medicine, energy, and environmental science. But however, nanomanufacturing also presents significant challenges, including the need of specialized equipment, the need to maintain strict environmental safety and standard, and the need to ensure the quality and consistency of the manufactured products. As such, manufacturing is an active area of research and development with ongoing efforts to improve efficiency, scalability, and safety of manufacturing process. So, the nanomanufacturing is to develop new products and technologies nga mas efficient and mas effective. So we have here the two fundamental approaches in nano manufacturing. First, we have the bottom-up fabrication. In manufactures products by building them. It manufactures products by building them up from atomic and molecular scale components. The bottom-up fabrication is a technique used in technology to build nanoscale structures. It says here that building them up, it to build nanoscale structures and devices from individual mole, mole, molecules, atoms or molecules. In the bottom-up fabrication, the building blocks are guided by external factors such as electric fields, physical templates to form larger structures. This approach allows for size control over the shape, size properties, and resulting nanostructures and enables to create a new materials and devices with novel properties and functionalities. And here they bottom up. Bottom up atoms to cluster to nanostructures, while the top down is a trimmed down large pieces of materials into nanoscale. Kumbaga kabaliktaran siya ni bottom up. It kanang iyang gina trim down or gina break down into pieces, bulk into fragments para kuan sa nanoscale. So here are the examples of the bottom-up fabrication and the top-down. The bottom-up fabrication, the dense lithography, the self-assembly, and the roll processing. With the use of these techniques, nanomaterials are made more durable, stronger, lighter, water-repellent, ultraviolet or infrared resistant, scratch resistant, electrically conductive, anti-reflective, artifact, antimicrobial, self-cleaning, among others. And daghan pa to siya. So, and lastly, a product of nanomanufacturing is kaning a 16 gauge wire, approximately 1 to 1.3 millimeter in diameter, made from carbon nanotubes that were spun into thread and the same wire of the 150 ply spool. So imagine how kagamay ani nga wire. So kanang nanomaterials are very important in developing new techniques, new kanang technology for the enhancement and advancement of the world. So that's it. The nano manufacturing product, ang isa sa ano nga product sa manufacturing is the gauge wire, ana siya 1.3 millimeter ang diameter. So for the sumpay in this topic, for the continuation of this topic, will be discussed by Danica, and that will be all for the introduction and for the nano world, the nanotechnology, the nanoscience, who are the scientists, the scale, how small, how tiny it is, and paunsa siya makita how to view the inventor, the engineers, the scientists of the microscope that are being used para makita ang mga nanomaterials and what else, and lastly the nano manufacturing. Okay, the fundamental and their product. So that will be all for my topic, for my report, the nano world. So hopefully guys you understand. That's it, and